Today our topic of discussion is enumerable set. So what is enumerable set? In the previous lecture we discussed about equipotent set. If you didn't see, you can check it my playlist. And this enumerable set is related to equipotent set. Okay. So in equipotent set there exists a bijective mapping from a set to a set. Okay. But here some of the difference. What is the difference? A set A is said to be enumerable set if A is equipotent with the set N. So what there is the difference? The set A is equipotent with the set N. So there exists a mapping A, मतलब इसका मीनिंग जो कहना चाहता है, there exists a mapping A from such natural number to A is bijective. Here this is not changeable. What is the difference between equipotent and enumerable set? This goes from natural number to any set, but in equipotent set there doesn't have this natural number. Okay, so let us try an example. This enumerable set have another name that is called countably infinite set. We discuss how an enumerable set is described. When a set is finite and contain an element, then how we describe? The element described as A1, A2, A3, An. Elements are described. And the finite set, how we describe? 1, 2. This is a finite set contain an element. Finite set description. So this is not like that. This is A1, A2, finite element, or this is finite set. Okay. And when A is enumerable, then what happened? Then there exists a mapping from natural number to A. There is a bijective mapping from natural number to A assigned to each n belongs to n an element f of n belongs to capital A. So for any n's belongs to n, there exists an element if n belongs to that set. Okay. So thus the elements of A, that's this set, are described as f of 1, f of 2, f of n, and so on. And the elements are described A1, A2, An, indexed by the set of natural numbers. Okay. So the examples are, let the set N is enumerable because the set of natural number is enumerable, because there exists a mapping from n to n defined by f of n equals to n for all n belongs to n is form a bijective mapping. So we should check this mapping bijective or not. You can check, and I tell you another some example of enumerable set and tell you some example of non-enumerable set. So let S equals to 2, 4, 6, 8, 10. This is also enumerable set because we define from f from n to s by f of n equals to 2n for all n belongs to n. This is a form a bijective map. Okay. The another example is set of integer is enumerable, but how that is enumerable? That is f from n to z by f of n equals to n by 2 for of n belongs to n. This is formula by z. Now I say that an example which is not a enumerable set. The first condition, first example is in the open interval 0 1, that's equals to x belongs to real numbers such that 0 less than x less than 1. This is not an enumerable set. Number 2, the set of real number is not enumerable. The set of real number is not enumerable.